Alright, so for this game, we have what is largely a sequencing game, and I guess not largely, this is a sequencing game. We effectively have 5 positions to work with, so we can set this up accordingly. We just have 1, 2, 3, 4, and 5. And the elements themselves happen to be G, H, R, and then we have S and T. So nothing especially out of the ordinary so far. We just have 5 people, 5 positions. This is 1-to-1. Nothing especially exciting there. And I guess from there we can go straight into the rules. So the first rule tells us that H has to go at some point before R. So we can line that up accordingly. H has to go before R. Next, the second rule tells us that if G performs before T, then R and S will also go before T. So this one's a bit of a messy rule, but essentially we can kind of create a conditional statement that says that if we have G before T, then what will have to happen is that we'll have to have both R and S. They will both also have to go before T. The thing is, though, remember, as much as possible, if you have an opportunity to build up the rules, it's always a good idea to do that and to kind of make connections as you go. So first of all, somewhat a bit more obviously, we can say, in this scenario where G is before T, obviously G is still before T, so we can latch it on here, because in this scenario, that means that all 3 of R, G, and S are going to have to go before the T. On top of that, as far as R is concerned, we already know that R is after the H, which means that in this scenario, that's still going to hold. So we can kind of tack on that you'll have to end up with an H before the R as well, which means that this kind of builds out really nicely. This means that if G is before T, then effectively all of these connections will have to be maintained. In fact, you'll notice that T then becomes incredibly restricted, because that means that T is effectively after everybody. Now, that said, keep in mind that this really only applies if G is before T. If G is not before T, we actually could end up with roughly the same thing, or not. We could really end up with anything. We wouldn't really know anything about what would happen if we didn't have G before T. But in the scenario that we do, it gets really restricted, which is nice. Next, the last rule then tells us that H has to go either before both S and T or after both S and T. So effectively that means that we only have really 2 major possibilities here, right? We know that either we're going to end up with the H as having to go before both S as well as T, or alternatively we'll have to have H go after both S and T. There's only these 2 possibilities in terms of what could happen in general for the game. The thing is, though, again, we can build it up based on what we already have so far. So for one, this on the easier side of things, we know that effectively we're going to have H before R still, right? So if H still has to go before the R, that now means that in this scenario, H, we can kind of tack on that R is going to follow. And then in this scenario, in the second one, we're going to have the H still before R. So we can kind of play with that. On top of that, we also know that there's still this outstanding rule that if G is before T, then you'll notice that all of these people really will have to go before T. Now, in the first scenario, that could still happen. We could still have G go before the T, and then T would have to go after everybody else. That's still plausible. But you'll notice that in the second scenario, that could never happen, because here, if you trigger G before the T, there's no way to have T go after everybody, because T is certainly before both H and R, which means that in the second scenario, we can say that this condition cannot be triggered. We can actually further this to say that we can't have G before T, so it stands to reason that T will have to actually go before the G. So this is pretty good. Now, we can actually take a step further here, because in this scenario, we can still say there's 2 major directions this can take. Either we're going to trigger this, G before T, in which case we're going to have some consequences, or we're not, in which case G would go after the T. So what we can do is we can further kind of expand this out. We can say, you know what, we only have 2 possibilities for what could happen with this. And actually, before we do that, it's worth recognizing, at this point, what we already have is effectively an exhaustion of how the, elastic band relationships are going to work, right? Because either this or this always has to happen, right? No matter what, which means that we kind of have 2 major plays for how the relationships are going to work out. And then this scenario, we can kind of further sub-exhaust and say that, you know what, there's only 2 different directions this scenario can go. So you know what, let's kind of play them out. We can say, In both scenarios, we're obviously going to have H before all three of S, R, and T. But in one scenario, we're going to have the G before the T. But now, if we have G before T, as we said earlier, T ends up having to go after everything effectively. So what we can do is we can further this out. We can expand this setup and say that T is going to actually end up going after all of these people as well. And we can just move the G a little bit closer here to say that G is still going to have to go before T. Or alternatively, in this scenario, we said we would kind of not trigger that rule, or in other words, we're not going to have G before T, we're going to have G go after the T. And as we said earlier, if G goes after the T, we know nothing. There are no consequences to G going after T, so that kind of stays a little bit more open. So essentially, what we really just did here is we created three major plays for what could happen with this game. No matter what, these aren't really definitive setups per se, but the relationships have to hold. Either we're going to have this elastic band of relationships, or this elastic band of relationships, or this one. No matter what, one of those three possible combination sets is going to have to work. Now, we can kind of take this a step further now, because in some of these, you'll notice that we have some pretty heavy restrictions. In the first scenario, for example, we said actually already, T, you'll notice, has to go last because T is effectively after everybody. In this scenario, you'll actually notice that H ends up being before everybody, which means H is actually going to have to go first here. And this scenario is a little bit more flexible because the last position could still be either R or G, and the first position could still be either S or T, so everybody has a little bit of flexibility to play with here. So from here, I guess we can jump into the questions themselves. So the first question we do here is, as usual, the first question, which happens to be a local question, so we would do it first no matter what. The question asks, if G is first, in which of the following could be true? Well, let's play this out. If G happens to be first, I guess the question becomes, what does that mean for us? Well, you'll notice that this scenario could work with G going in 1 because G could stretch all the way back. But this scenario definitely wouldn't work because G has to go after the T. And this scenario wouldn't work because G is after both T and H as well. Which means that in this scenario right now, if we have G in 1, the only scenario that would work with, the only combination set is this one, really. And then from there, we can take a few steps further because here we know that T is after everybody. So T is definitely going to go fifth now. We also know that of the remaining elements, H, S, and R, we're going to have H before both S and R. So we can line that up. We can say that H is going to have to be in 2. Now, we're not exactly sure what's going to happen with R and S one way or the other, so we can just kind of split this. We can say this will be an R or an S in positions 3 and 4. And then from here, we can take a look at the question. The question asks, which of the following could happen? Answer choice A, H in 3, and that definitely cannot happen because H is already in 2. Next, R is in 2. Nope, that's already H. Next, R is in 5, and no, that's already T. Next, S is in 3, and actually maybe, arguably, S and R could kind of shuffle back and forth here, right? We don't really know what's going to happen between the two of them, so that's a little bit more flexible, which is perfect. That is a viable answer choice here. Just in case, though, taking a look at answer choice E, T is in 4. No, we definitely know that the fourth position has to be one of R or S, so that would disqualify answer choice E, and that leaves us with answer choice D as the best answer to question number 6. Next, question numbers, well, you'll notice that 7, 8, and 9 are all global, so we're going to leave those be for just the time being. Let's jump ahead to question number 10. So number 10 says, if S goes first, well, let's play this out. If we happen to have S in the first position, the question now becomes, what does that tell us? What does that mean? Well, again, let's go back to our templates. You'll notice that this scenario no longer works because S is after H. This scenario is still viable. S could go potentially first. This, not so much. S has to go after H here, which means we're stuck in this set of relationships. Now, in this set of relationships, you'll notice that once we get rid of S, the rest of the elements, they all seem to go after T. T has to go before H and G, and by extension, R as well, which means that you'll notice that in this scenario, T is going to end up having to go second. Now, after T, we have a little bit of flexibility because we know that H is going to go before R, but the thing is G can kind of shuffle them. He can go in before them, in between them, or after them as well. So we have a little bit of movement on G in a sense. We could leave this open, or alternatively, another thing you can do is if you wanted to signify the relationship between H and R, you could do something like saying that 3, 4, and 5 are basically going to be G/H before R. So the idea is that G can kind of shuffle back and forth, but you'll still have to maintain a relationship where H is before the R. So the question itself now asks, which of the following must be true? Now it's worth noting we can actually take a bit of a shortcut here because all of the answer choices, they pin down a person to a position. And aside from the question which told us that S is first, the only person whose position we know right now is T. So we can kind of just look for that. And the best answer ends up being E. T will have to go second. And that's question number 10. Next, question number 11. If S happens to be fifth, well, again, let's kind of see what we can do with that information. So if S happens to be fifth, the question as usual is, what does that tell us? What does that effectively mean for us? Well, first of all, we know that in terms of our possibilities, this one breaks, right? Because S has to go before T, so that's out of the question. This also doesn't work because S is before H and R, so that's not going to happen, which means the only scenario where S can go fifth is this one right here. Now, in this scenario, what did we say? We said that H ends up being before everybody, which means we can kind of lock that down. We can say H is going to be in position number 1. And now, aside from H and S, all we're really left with are R, T, and G. And it's a very similar situation. We know that T has to go before G, but R can shuffle them all back and forth, right? R can go before them, between them, or after them. So we can kind of very similarly say we're going to end up with an R/T before G. We don't exactly know the exact order, but we're going to have to still maintain T before G with R going anywhere it wants to. So the question asks, which of the following must be true? Well, again, the only thing aside from S going in 5 that must be true is that H is first. So we can kind of look for that. And that is answer choice B to number 11, which is the correct answer choice. Next, let's bounce back to the global questions. So the first global question that we had here was number 7, which said, which of the following pairs could be the first and second students to perform respectively? So who can go into positions 1 and 2? Well, let's see what we can do with what we have. Answer choice A, G and T. Now, it's worth noting we've never seen the possibility for G and T consecutively in that order, but if we take a look at our exhaustions, what do we know? In this scenario, T would have had to be 5, so there's no way to do GT in 1 and 2. In this scenario, T is before G, so that's definitely not going to happen. And in this scenario, T is still before G, which means that also isn't going to happen. So you'll notice that there is no scenario where you can have G and T go into positions 1 and 2 in that order. Next, answer choice B, H and G. Could we ever have H and G in 1 and 2? Well, again, we haven't seen that possibility yet, but let's see what we can do with our scenarios. Now, in this scenario, it's actually worth noting that actually looks like it could work, no? Because we could have H in number 1, and then G could stretch back to go into number 2 right after it, right? So that actually seems very plausible. Now, to be fair, that's actually all it takes, but just in case, let's take a look at all our other scenarios. In this scenario, H is not going to go first, so that's out of the question. And in this scenario, H and G would have to have T between them, so you would never have H and G in positions 1 and 2 respectively. Nevertheless, this is all we need, right? Arguably, we could have had H number 1 here, and then G could have immediately followed in number 2. So answer choice B is actually looking pretty good right now. Just in case, though, let's take a look at the other ones. Answer choice C, could we have R and T in positions 1 and 2? Again, we haven't seen that historically, but in terms of our scenarios, well, here, R is after H, so it's not going to be first. Here, R is after H and T, so it's not going to be first. And here, R is still after H. In fact, we had a rule where R had to go after H. So we definitely can never have R and T in 1 and 2, respectively. Next, answer choice D. S and R, can we do that? Well, you'll notice that in this scenario, S would never go first because it's after H. In this scenario, S could go first, but we could never have S and R, respectively, because H would have to go between them. And in this scenario, H is first, so S is certainly not going to be. So answer choice D also gets disqualified. Next, T and H. Well, let's take a look. We know that in this scenario, H is, well, let's say T is not going to be first. In this scenario, T is also not going to be first. Now, in this scenario, T potentially could have gone first, but if we did that, there's no way to place H in second because H would have had to be after the S, which means if we did T1 and H2, S has nowhere to go prior to the H, which means answer choice E also doesn't work. The best answer to question 7 then becomes answer choice B. Next, question number 8. Which of the following pairs cannot be students 4 and 5, respectively? Well, a very similar question. Let's see what we can do. G and T. Can we ever have G and T in 4 and 5? Again, historically, we have never seen that happen. But in terms of our possibilities, well, in this scenario, arguably speaking, we could seemingly have T in the 5th position, and then G could have gone 4th. So it actually looks like G and T could go into 4 and 5 respectively. So answer choice A gets disqualified. Next, answer choice B. Could we have H and R in 4 and 5 respectively? Now that actually we saw an opportunity for right here. We could have had H and R, and then G would have gone into position 3. So B definitely could have happened. Next, answer choice C. Can we do R and T in 4 and 5 respectively? And again, we've actually got history for that. We've seen the possibility here. R and S could have split, which means we could have had R in 4 and T in 5. So that disqualifies answer choice C because that could have happened. S and G, can we do that? Well, we haven't seen that historically, but in terms of our templates, let's take a look. In this scenario, T would be 5, so that's not going to happen. We can't have SG with the G in 5. In this scenario, now S would have to go before H and R, which means that there's no way to do SG in 4 and 5. This scenario, though, actually here, it looks like it could work, couldn't it? Because we could easily seemingly have G in the 5th position, and then S could stretch down into the 4th position right before it, right? S and G are relatively open elements here. So it actually looks like answer choice D could have happened. You could have had S and G in 4 and 5 in that scenario. Let's take a look at E. Can we have T and R in 4 and 5 respectively? Now again, in terms of our history, we've never seen that happen. Now in terms of our templates, here that would never happen because T could never go 4th here because T is obviously 5th. Now in this scenario, T and R would not go 4 or 5 because T has to go before a bunch of other people, right? So there's no way to place T in 4th. Now in this scenario, could we do T and R in 4 and 5? Well, actually no, also no, because if we place T in 4, then G would have to follow it in 5, which means that there's no way to do T and R in 4 and 5, which means answer choice E is what we're looking for. This is the one pair of people that cannot go into positions 4 and 5, respectively. Next, lastly, question number 9. So number 9 says, which of the following pairs cannot be 2 and 3, respectively? So a very similar question, but now we're dealing with positions 2 and 3. So answer choice A, could we have G and H in 2 and 3, respectively? Now looking at the history, again, we haven't really seen that happen with G and H in 2 and 3, but let's take a look at our templates and see if we can make it happen. Now, in this scenario, the thing is, there's no way to place G and H into 2 and 3 because even if we moved the G before the H, then everybody else, S, R, and T, would still have to go after. So if we placed G in 2 with H in 3, there would be no way to fit S, R, and T into the positions 4 and 5. Or in other words, there would be nobody to go first. So in this scenario, G, H, 2, and 3 would not have worked. In this scenario, could we do G and H into positions 2 and 3? Well, no, because if we did G and H in 2 and 3, there would be no way to fit S and T before those positions, because then there's only one space before them. So that wouldn't have worked either. Now, in this scenario, that's definitely out of the question because H has to be first here, so G and H certainly could not go second and third. Actually, that means that answer choice A is looking pretty good. It doesn't seem like there's any scenario where G and H could have gone into 2 and 3, respectively. Let's take a look at the other ones. Answer choice B, H and R. Could we have done H and R in 2 and 3, respectively? Well, actually, we have the history for it right here. We could have done H, and this could have been R or S. So you could have done H, R in 2 and 3. That disqualifies answer choice B pretty easily. Next, can we do R and T into 2 and 3? Actually, we have history for that as well, right? Because we had R here, which could have shuffled. So we could have done R in 2, T in 3, and then G in 4. So we could have done R and T in 2 and 3. That gets rid of C. Next, can we do S and G into 2 and 3, respectively? Now, that we haven't seen history for, but let's see if we can do that with our templates. Actually, in this scenario, that seems like it would be pretty easy because S could easily go immediately after H in number 2, and G, as long as G is not last, G is pretty flexible, so we could seemingly do S in 2 and G in 3 in this scenario. So answer choice D seems like it could very well work. And answer choice E, could we do T and S into 2 and 3 respectively? Well, if we did T and S, could we do that? We haven't seen the history for it. This scenario obviously wouldn't work because T has to go 5th. Now, this scenario, actually this also doesn't seem like it would work, because if you placed T in 2 and S in 3, then effectively everybody else, H, R, and G, would have to go after, and there's no room for that. What about this scenario? Now in this scenario, yeah, this is viable because we could have placed T immediately after the H, so T could have gone into 2, and then here S could have gone immediately after, because it's worth noting S is completely flexible. As long as S is after H, we're good. So we could have easily done T in 2 here, and then S would have gone into 3, which means T and S could go into T and 3 respectively. The only one that cannot go into those positions are G and H. Best answer to number 9 is A.